Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about radiation pattern measurement. So need of the antenna measurements. So to ensure the antenna meets this specification and to characterize the antenna. So typical parameters of the antenna are gain, bandwidth, radiation pattern, beam width and impedance, etc. So these antenna measurements are very important. So radiation pattern is mainly the graphical representation of the antenna radiated field. So here the radiation pattern measurement, the coordinate system used. Here the spherical coordinate system for the radiation pattern measurement is given. Here we consider the azimuthal or longitude angle. It is similar to the Cartesian coordinate system, and we use the radius vector small r. It is taken from the origin of the spherical coordinate system, and it is directed towards the point P where the antenna is located. So at the distance from the antenna to point P where the measurement is taken, and also we taken the angle of theta. So and then circle of constant polar angle or latitude angle is taken for measurement. So this is the spherical coordinate system used for radiation pattern measurement. So there are two procedures suitable for this. First procedure is low frequency antenna measurement. Second procedure is for high frequency antenna measurement. So radiation pattern means the field strength at fixed distance from the antenna as a function of radiation. So here it gives the field strength at a fixed distance. So it uses the spherical coordinate xy horizontal plane, xz vertical plane. So antenna type, here we have a horizontal antenna and vertical antenna. So the E-plane pattern is chosen for XY plane, theta equal to 90 degree and phi varies. And for the H-plane pattern, XZ plane is taken, we have our theta vary and phi equal to 0. For the vertical antenna, we use XZ plane and theta varies and phi equal to 0. And H-plane pattern, we use XY plane, theta equal to 90 and phi varies. So horizontal antenna used for the earth to earth communication, and vertical antenna used for earth to space communication. So this is the arrangement for the radiation pattern measurement, where we have the transmitter or oscillator, and through the signal is given to the antenna through the RF cable, and transmitting antenna is the primary antenna. On the other side, we have the antenna driver units, where antenna support shaft is given, and it is the antenna under the test, which is the secondary antenna. So like this we can measure the radiation pattern from the transmitting antenna. So first procedure, primary antenna is kept stationary, secondary antenna is moved along the circular path with the uniform radius. So secondary antenna is the directional one, if it is always aimed at the primary antenna. So primary antenna is transmitting. The field strength readings and the direction of secondary antenna with respect to the primary are recorded along the circle at different points. So the plot of radiation pattern is either in polar form or rectangular form. So second procedure, both the antennas are at fixed position having suitable spacing between them. So the primary antenna is rotated and secondary antenna is transmitting. So that field strength readings and direction of the primary antenna with respect to secondary antenna can be made. The readings are taken at number of points. By stopping the rotation of primary antenna for recording the readings, or continuous reading can be taken if the pattern recorder is available. So like the second procedure is taken. For the radiation pattern measurement, primary antenna is in transmitting mode, secondary antenna is the antenna under test. So the secondary is coupled with the rotating shift and is rotated using the rotatory mechanism. To measure the relative amplitude of the receiver field, an indicator is used along with the receiver. So for the E-plane pattern measurement, the antenna support shaft is rotated with both the antennas horizontal. For H-plane power measurement, the shaft is rotated with both the antennas vertical. So this is the distance requirement for the receiving antenna and transmitting antenna aperture. The minimum distance r should be greater than or equal to 2d square by lambda. Uniform requirement experimental setup for antenna test, where primary antenna transmitter and secondary antenna is the antenna under test. So distance exactly equal to r, no interference in between the path line of sight, and mount the antenna on tall building. So these are the requirements for the measurement. So let's take the assessment, explain the concept of this experimental setup. Thank you for listening this lecture.